Good evening, sir.
Good evening. Just tell me what we had done in last class.
Sir, in last class, we have done till average speed and average velocity.
Now, next term is non-uniform motion. If a body covers unequal distances in equal time gap, so it is called non-uniform motion. If body covers unequal distance in equal time gap. So we may divide this particular part into two terms. First is called uniformly accelerated motion. It means acceleration would have some constant numerical value. Suppose a is equals to 2 meter per second square minus 5 meter per second square and so on. So this is termed as uniformly accelerated motion. Now we are confined to define along horizontal path only first. So first of all, what do you mean by acceleration? In last class, I defined you what do you mean by velocity. So velocity is nothing but a rate of change of displacement. Similarly, you may define this acceleration as rate of change of speed, or velocity is termed as acceleration. The rate of change of speed or velocity is called acceleration. So to define this particular motion, we use different equation of motion. You may have learned only three equation of motion, which is B is equals to U plus AT, first equation. S is equals to UT plus half AT square as second equation. B square is equals to U square plus of 2AS as third equation. And S nth is equals to U plus A by 2 times 2L minus 1 as fourth equation. Now we have certain limitation to use these different four equations. I'm defining you. First, in all of these equation of motion, we have to calculate first acceleration. Then we apply different equation according to the given condition. First equation, which is V as final velocity, U as initial velocity, and T is time. So it is termed as velocity time relation. Second equation is displacement time relation. Third is velocity displacement relation. And fourth is called displacement or distance traveled by body in nth second. I'm defining what do you mean by nth second. In this whole part, U is called initial velocity. It means velocity at t is equals to 0. Similarly, V is final velocity, velocity at any instant of time. S is displacement or distance, and S nth is distance traveled by the body in nth second. Is it clear to this part?
Yes, sir.
Just write it down.
Done, sir.
If you are done,
Done, sir. Done, sir.
I'm defining a limitation of these equations. Suppose you have path as this. Starting from 0, 1, 2, 3, and so on to n. So before n, it will be n minus 1. And you have n steps like this. So from starting time to that time gap, from this point to this point, it is termed as period of time. From starting to that point. So it is termed as period of time. So the above three equation will be valid only for this period of time from starting to that time gap. Next is, if you have to calculate between consecutive time gap between these terms. So this is termed as first second, this is second second, this is third second, fourth second, and 5 second. So these time gap is nothing but time between consecutive equal time interval. So these are time gap, or we'll say equal time gap between consecutive intervals. So this is termed as point of time. So the last equation, that is S nth, is valid for this part, and all above three equation is based on this part. Is it clear?
Yes, sir.
Okay. Now we have certain assumptions to define this equation of motion. First, if body is starting from rest, Take initial velocity to be 0. If it is finally stopping, take v to be 0. If it is going uniform motion, so a would be equals to 0. So v is equals to u. These are certain limitations and rules to define equation of motion. Just write it down. I'm giving you examples to apply these.
Done, sir.
Done, sir.
I'm giving you one problem related to this. Body starting from rest, accelerates uniformly and covers 8 meters in 4 seconds. Find first acceleration of body, second distance traveled in third second, third velocity at t is equals to 5 seconds. Try to solve. See in this part, body is starting from rest. So you will say initial velocity would be 0. Uniformly and covers 8 meters in 4 seconds. So S would be 8 meters and time is equals to 4 seconds. This particular time is termed as period of time. So just use second equation of motion and try to find acceleration from there. Then put fourth equation of motion in which time is third second. So just put n is equals to 3. You will get this part. Similarly, using first equation of motion and t is equals to 5 seconds, you will get this part. Is it clear for us?
Yes, sir.
Try to solve. Good, Ifra. So just check your calculation. Just see equals to ut plus half a t squared. U is 0, so this whole part would become 0. S is 8, half a we have to calculate, and t is 4. So on squaring, it will become 16. 16 by 2 will be 8. So 8 times of a is equals to 8. So a is equals to 1 meter per second square. Is it clear for us?
Yes, sir.
Good, Ifra. Put the value of n to be 3, you will get second answer. Good, Ifra. And third part, just use first equation of motion. Try to solve for us. second part, u is 0, is 1, plus c plus n is 3, so 2 into 3 is 6 minus 1, 5. It will be 5 by 2.5 meter. Was similarly,
Sorry, sir.
if you put all these values in this part, u is 0, a is 1, and time is 5. So it will be 5 meter per second. Is it clear?
Yes, sir.
Have you written till this?
Yes, sir. Yes, sir.
Okay. A body covers 9 meter in third second and 13 meter in fifth second. Find initial velocity and acceleration. In this part, we have nth second as 3 and distance traveled in nth second is 9 meter. Similarly, nth second is 5 and distance traveled in that time is 13. Use fourth equation of motion and put all these values. You will get two different equations. Just simplify it and you will get u and a. Good, Afra. part we have 9 meter is equals plus a by 2 is 3. So 3 into 2 is 6 minus 1 5. Take this as equation first. Similarly, 13 meter is equals to u plus a by 2 is 5. 5 into 2 10 minus 1 9. Equation 2. Just subtract these two equations. You will get a. Put the value of a in any of these two equations. You will get u. On subtracting, it will become negative, negative, negative. So 9 minus 13 would be minus 4. U and u becomes cancel out. A by 2 is taken out common. 5 minus 9 would be minus 4. So this minus 4 and this minus 4 will cancel out. So you'll get A is equals to 2 meter per second squared. Now, if you put this value in any of these above two equations, you'll get U is equals to 4 meter per second. Fawaz, is it clear?
Sir, how you got U?
If you put the value of A in any of these two equations, suppose in first equation,
Okay.
9 is equals to U plus A by 2. A is 2 divided by 2 into 5. So this 2 and this 2 will cancel out. So it will be U plus 5 is equals to 9. So U is equals to 9 minus 5. So it will be 4 meter per second. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
I'm defining you some application of this equation of motion. First is reaction time. Suppose a driver is driving a car at some initial velocity at this instant, and you observe any individual in front of him on the road at this instant. So on observing this individual, his mind take reaction against it, and then brakes being applied. In this whole process, it will take some time, and this particular time is termed as reaction time. You must have learned in previous classes in biology about two terms, stimulus and response. Stimulus is nothing but any change in surrounding against which our body get responded back. So the total duration of time taken by brain to get responded back against any stimulus is termed as reaction time. Is it clear?
Yes, sir.
So reaction time is time duration taken by brain to get responded against any stimulus. In this case, this individual is any stimulus against which we have to respond. Initially, this car is moving at this much velocity. And at this instant, the driver of this car observed this individual. So this is point of observation. On observing this individual in front of him, his mind get responded back, and then brakes are applied. During this whole process, this car would move this much amount of distance. So distance traveled by car from this point to this point is termed as reaction time. During this, acceleration would be 0. So using second equation of motion, s is equals to ut plus half at squared. A is 0, so this will be 0. S is equals to u into p. This is called reaction time. So now, at this particular instant, brakes will be applied. On application of brake, this car would get retarded. So retarded motion, so that this car will get stopped finally at this point. So final velocity of this car will be 0. So the total distance traveled by car from this point to this point is termed as stopping distance. So using third equation of motion, v square is equals to u square minus of 2as, in which a is retarded motion, so we'll take ar. Final velocity of body would be 0. If you calculate s, it will be u square divided by 2 times of ar. This distance is termed as stopping distance. Is it clear?
Yes,
Yes,
sir.
sir.
Just write it down. I'm giving an example.
Done, sir.
Done, sir.
Driver having a reaction time is 0.5 second. Driving a car at 72 kilometers per hour. Find total distance to get stopped if the retardation produced by brake is 2 meters per second squared. In this question, we have reaction time, we have initial velocity in kilometer per hour. So first of all, convert it into meter per second. And we have retardation as 2 meters per second squared. Just put all these values in this part, let's say this is S1. In this part, let's say this is S2, and add them. Try to solve. Now just check your calculation.
Okay, sir.
This question, we have a reaction time as 0.5 seconds. Initial velocity of car is 72 km per hour. So just multiply it by 5 by 18. You will get
So it will
20
be
meter per
20.
and retardation produced by brake is 2 meter per second squared. Put all these values in this part as well as in this part and add. Now just check your calculation. Good Fawaz. Good, Fawaz. Just add them. Just see if you have to calculate S1, which is U times TR, U is 20 and reaction time is 0.5, so it will be 10 meter. Stopping distance is U square by 2 times of AR. U is 20 into 20. 2 into AR is 2, so it will be 100 meter. Now, total distance traveled is S1 plus S2, so it will be 110 meter. Is it clear, Fra?
Yes, sir.
Okay, I'm giving you. So this is all about uniformly accelerated motion along horizontal line. I'm giving you one more problem related to this. In competition, a car moving at 20 meter per second stops and 20 meter on applying brake. Find stopping distance if speed of car is 40 meter per second. Try to solve. So you'll say stopping distance is equals to U square by 2 times of A. So AR is retardation caused by brake will be always constant. So this distance, that is stopping distance, will be proportional to U square. So from here, you will say S1 over S2 would be equals to U1 over U2 whole square. Now just put the value of S1, U1, U2 and try to find S2. Is it clear?
Yes, sir.
Try to solve. U1 is 20 meter per second, S1 is 20, U2 is 40 meter per second. You have to calculate S2. Good, Ifram. Fawaz, just see, S1 is 20, divide by S2, we have to calculate. U1 is 20, divided by U2, which is 40 whole square. So 20 into 2 whole square becomes 1 by 4. So on cross multiplication, you will get S2 is equals to 80. Okay for us?
Okay, sir.
Any doubt till this?
No, sir.
Okay. So this is all about equation of motion or uniformly accelerated motion along horizontal line. Now the next term is motion under gravity, or
Sir, can you go back?
okay,
Okay. Okay, sir. Okay, sir.
or free fall. For this, I'm giving you some concept, and on using those concepts, you will be able to define all of the problems. Just forget all of the previous concept which you have used in class 9 about gravity or motion of gravity. So first is take point of thrown of body to be origin. Using this origin, all of the upward term will be taken as positive, and all of downward term will be taken as negative. Next is, as gravity always act along downward direction, so it will be taken as negative always. Since gravity acts downward, so taken as negative always. Next is, for a system, all object which is inside the system of any object or any body, so all body in a system must have same velocity, or you say object will acquire velocity of system whose it is a part. Suppose if you are going in a car, so the velocity of car and velocity of you must be same at any instant, so that your position and position of car must be at same instant of time. In this whole part, we just neglect air resistance. So air resistance is neglected. Any doubt in this whole segment?
No, sir.
We just write it down.
Done, sir.
Done, sir.
Now next is, suppose this is surface of Earth. through which a body is thrown upward. Let's say at some initial velocity u. So it will move along this path, and after attaining some height, it will reverse back to the ground. So this will be highest point of the projection. So it will be highest point. At highest point, velocity of object would be 0. It means object would momentarily comes to rest and then it reverses its direction to go back. So that acceleration or velocity of body at highest point would be 0, but acceleration would be minus g at this instant. So you will be asked to define a point where velocity of body is 0, but it is still accelerating. So you will say at highest point of free fall, object will have 0 velocity, but still it is accelerating. Is it clear?
Yes, sir.
Yes, sir.
Now, the total time taken by this body to ascend from this point to this point is TA. Similarly, total time taken by this body to descend from this point to this point is d. So you will say for same horizontal path, for same horizontal path or horizontal line, time of ascent and time of descent should be equal. Total time duration taken by this body to go up and return back is termed as time of flight. So time of flight is equals to time of ascent plus time of descent. Since these two terms are equal, so you will say time of flight is 2 times of time of ascent or 2 times of time of descent. Is it clear?
Yes, sir.
Next
Yes,
is
sir.
at any instant for same horizontal path. Let's say velocity of body while going up is v1, and at the same instant on returning back, velocity of body to be v2. If there is no air resistance, and since these two paths at same horizontal line, so v1 and v2 must be equal in magnitude, but they would be opposite in direction. So we'll say at same horizontal position, v1 in magnitude must be equals to v2. Just write it down. I'm giving you some problem related to this.
Done, sir.
Vanas, done.
Done, sir.
a boy throws a ball upward and receive it in 4 seconds. Find first velocity of throw, maximum height it would attain. Take gravity to be 10 meter per second squared. Question we have, let's say this is surface from which a ball is thrown upward. So it must go along this direction and return back to this. So the total duration of time taken by this ball is 4 seconds. So calculate time of ascent and time of descent. So it will be half of time of flight. Time of flight is 4 divided by 2, so it will be just 2 seconds. So time taken by this body to go from this point to this point is 2 seconds. Initial velocity of projection is u, and at highest point velocity would be 0. So first use first equation of motion, you will get u, then use third equation of motion, you will get height. Ifra, just check your sign convention. Use first equation of motion, then third equation of motion. As just see in this, final velocity at highest point will be 0. Initial velocity you have to calculate acceleration is minus of gravity, and time is just 2 seconds. So on simplifying, you will get 20 meters per second. Now just put this value in this part. V is 0, U we have calculated, A is minus 10, and S is height. Beautiful. If you put in third equation, V is 0, U is 20 into 20, 2, acceleration is minus 10, and displacement would be h. So move this term to left hand side, you will get plus 20 into h is equals to 20 into 20. So h will be equals to 20 meter. Is it clear for us?
Sir, what is S?
S is displacement. So in this part, while going up or down, it will be termed as height. Okay.
So S
if
is
you take
0.
from this part, if you take this particular term to be origin, so while going up, so the total displacement would be along vertically upward direction. So you have to define from this point to this point. So this will be h. Is it
The
clear?
ball will come down, so it will be 0.
After attaining this much height, it will return back. So I'm using just 2 seconds only. Okay.
Okay, okay, sir.
That's why I'm taking this part to this part. Avaz,
Done, sir.
done? Okay.
Yes, yes. Sir.
There is next concept, dropping of a body. Object will always acquire velocity of system whose it is a part. So let's say first, if a body is dropped from any building, so we have to take this particular point of thrown or dropping of a body to be origin. So if this is origin, all of the quantity which is along downward direction, so it will be taken as negative. So height of building must be calculated along downward direction. from this origin, so it will be taken as negative. Gravity is always acting towards down direction, so it will also be taken as negative. And since this building will be initially at rest, so u is equals to 0. So in this part, s would be equals to minus of h, acceleration would be equals to minus of g, and u is equals to 0. So according to the given condition, whatever you have to calculate, just put these values and you will get answer. Next is, suppose there is a hot air balloon which is ascending at some initial velocity v0. And let's say there is a ball in it. Now suppose this ball is being dropped at this instant. So in which direction this ball moves initially? Upward or downward? Ifra?
Downward.
Okay. Fawaz, in which direction this ball have initial velocity? Upward or downward?
Sir, downwards.
It was initially a part of the system which was initially moving along vertically upward direction. So this ball must have a velocity along upward direction initially. So it will have v0 velocity in upward direction, due to which this ball will move along vertical direction to some height and then return back to the ground. Is it clear?
Yes, sir.
Yes, sir.
Since this ball was a part of this hot air balloon, so this must acquire velocity of system whose it was a part. So this hot air balloon was initially going up with this much velocity, due to which this ball would have same velocity as of system. So due to this velocity, it will move upward to rise some height to reach at this highest point, so that final velocity at this highest point would be 0. So height attained by this ball while going up would be small h. So while going up from this point to this point, displacement would be plus h, initial velocity would be plus v0, but acceleration always along down direction, so taken as negative. Now, if we take this particular position from ground, so this capital H is along downward direction, opposite in this particular point. So from this point to this point, displacement would be minus h. Initial velocity would be again plus of v0 as initial, and acceleration would be minus g. Is it clear till this part?
Yes, sir.
And there is one more condition in which, suppose if a plane is going along this path with some initial velocity, let's say u, and it has some packet which is being dropped from it. So on dropping, since this plane is initially going along horizontal direction, so this object must have velocity along horizontal direction only. So it will have velocity along horizontal direction. And since we are considering only vertical path, So you'll say there is no any vertical component of velocity for this object. Is it clear?
Yes, sir.
Just write it down. I'm giving you some problem related to this.
Done, sir.
Okay.
Done.
A hot air balloon is rising at 12 meters per second. Drops a ball when it is at 65 meters above the ground. Find time of flight. So in this part, we have this as V naught, this as displacement, which is capital H. Just use gravity to be 10 meters per second square and use this concept. Apply in second equation of motion, you'll get time of flight. Try to solve.
Sir,
Yes, Fawaz.
sir, in which formula we should put this?
In second equation, S is equals to ut plus half at squared.
Okay.
S is minus 65 using this. U is plus 12 using this, and A is minus 10 meters per second squared. Nabila, just wait for a few minutes.
Yes, sir.
S is minus 65, U is plus 12 into T, A is minus 10, so it will be 2 into 5. Now move each term to left hand side, you'll get 5t squared minus of 12t minus 65 is equals to 0. Now take product of first and last term and then factorize it. So 5 into 5 will be 25 and 13. So you'll break 12 as minus 25t plus 13t minus 65 is equals to 0. Take out common from both these two parts. So if you take 5t from this, you will get t minus 5 plus 13 from here. So it will be t minus 5. T minus 5 taken out common from both these two terms. So you will get, so it will be t is equals to just 5 seconds. Good, Isra. Is it clear for us?
Yes, sir.
Okay, just write it down.
Done, sir.
So just revise this whole part. In next class, I will define you some more concept regarding this, and then we will start non-uniformly accelerated motion. Okay?
Okay.
Okay then.